start at 3:30, right?
Yes. We can do this live, actually. Because so let's go ahead and get started. Appreciate it, everyone. Thank you for being here. My name is Michael Pritchard. I'm the Associate Dean for Research and Graduate Studies here at the Aerospace and Technology campus. And this week, this research forum, we're going to be covering the 7DOF motion platform initiative that we have going on here on campus. Come up to the camera. So I've got Timothy Bruner here, and he'll be kicking us off. But I also have Dr. Michael Atkin, who'll also be providing some color commentary as we go through the process, as well as our department head, our fearless leader, Troy Harding. Mr. Bruner, you are on.
Cool. So, good morning, everyone. We'll be talking a little bit about the new 7 Degree of Freedom platform here on campus, as well as some of the virtual reality use cases with combat flight simulation and opportunities for research and student engagement that it brings. For those on Zoom, I know I'm in the camera. I have a habit of moving around when I talk, so if I start to stray too far out, you can say something. But for now, yes. Say again? Oh, talk this way. Yep.
You can.
Cool.
Yeah.
Cool. Awesome. So
Yeah,
open coffee
you can
forum
talk this
things.
way.
Bear with me. In fact, I'll just stand over here. Okay. So we're going to go ahead and kind of dive into it. A little bit of an overview of this presentation. I'm going to start by covering what is the 7DOF platform, and then go into a little bit of the research opportunities, and then go into the student engagement aspects of it as well. So I'm going to go ahead and dive in, and I think I've got this presentation rigged with a button.
Mike Pritchard, your button.
Mind. There we go. There we go. Whoop. Back
too
one
far.
slide, please. There we go. So we're going to talk about what is it, the use case in this case. And one thing I'm going to drive home is the use case we're going to discuss today is one use case for this platform and the VR and augmented reality technology, but it is by far not the only one. So we'll look about research opportunities, training, human factors, and some other opportunities that this platform and the technology we're bringing to campus will offer. In addition, we'll look at some real world applications. Things are actually happening right now with the simulation software and some of the technology we'll be discussing. And then we'll kind of follow up with opportunities for student engagement and a current newly minted student club that now exists, built around some of this technology, software, and some of the really cool opportunities it brings. So next slide, please. So what is a 7 Degree of Freedom platform? I know we've got at least one roboticist here in the audience, so feel free to correct me if I misspeak. But 7DOF, 7 Degrees of Freedom. Degrees of freedom is typically used to express the movement capabilities of a robotic device. Think of your arm. You have different axes and planes of movement. You can rotate your arm. Similar concept. In this case, take a look at that diagram in the top right corner. That is actually a 6 Degree of Freedom movement diagram. It tells you how things move, what directions, where things rotate. Pretty simple concept. That 7th degree of freedom that we're going to be talking about when you hear 7DOF is actually an extra redundant axis of motion. Typically, it allows you to do something different. Like if I were to put my hand on a table, I can still move my joints without moving my hand from that table. There's something there that is redundant. It doesn't force a motion in an axis where I don't want it. And so K-State Salina campus has recently acquired a 7 Degree of Freedom motion platform. It's kind of in the background image. It may be a little bit difficult to see. That's cool because on the next slide, we'll talk a little bit about it in depth.
Yeah. Maybe.
There we go. So this is a picture of our platform. CCAS is the manufacturer from Australia. Really neat little company. One of the earlier slides in this actually had in the background a large aircraft simulation, like a 737 style cockpit you'd see mounted on top of one of these things. So 6DOF plus infinite turn, weight limit of about 3,300 pounds. The specifications are in the link. Nope, and I think, yep, thanks, Troy.
Thanks.
Uh-oh.
Good call.
Back one slide, please. There we go. So one of the things, again, I kind of said at the beginning, primary use case is immersive simulation, such as flight simulation, virtual racing, rovers, virtual presence, and more. Today, we're going to be talking about just one use case of many use cases. In fact, I know we have someone here in the crowd. I walked into the lab last night. They're working on sticking one of the Baja car frames on it to do a simulated Baja car. So there are a lot of different uses for this platform to explore in terms of research, student engagement, exploration of technology, and so on. So the punchline is this system combined with a push for robust augmented reality and virtual reality initiatives on campus gives us a lot of capability. And we're going to be exploring one of the really fun ones today, at least one that I really enjoy exploring with some really cool opportunities that come with it. It's essentially a blank canvas, which, I mean, artistically, white slide, nothing on it. Haha. Going for that cool idea there. So anyway, next slide, please. So high fidelity combat flight simulation. This is sort of an interesting thing. Me as a pilot and a UAS guy, I'm kind of the tech nerd of the aviation world, and I've been playing around with flight simulation since I was a kid. In fact, you'd be hard pressed to find a lot of aviators that haven't. And this is a particularly interesting use case for 7DOF and augmented reality and virtual reality because of the implications and applications. So why? Well, there are a lot of opportunities for research, partnerships, and other engagement. The student engagement side has been growing and flourishing, and industry and the research world, well, we'll talk about some of the use cases a little later on, but there's definitely some stuff happening in this realm that is fascinating, at least to me. So one of the big pieces of software you'll hear a lot about today, it's commercially available, called DCS World by Eagle Dynamics. They were originally a Russian company, now they're in Switzerland. And they do very high fidelity aircraft systems modeling and flight modeling. They'll do a full CFD analysis of each airplane and chunk it into a simulation. So there's some really cool stuff. One of the reasons it's so popular is it's readily available. It's pretty easy to work with. There's a lot of editing tools and modding software out there. It's very popular in the recreational world. You can go get a copy online. It's also popular in the professional world. You'll see people actually training with it. We'll look at some of those use cases. It also offers incredibly high level of fidelity and detail. I think in the email that went out, I dropped Dr. Pritchard in an F-16 and then in an Apache, and we ran through start sequences and takeoffs and avionics procedures. It's pretty neat.
It's pretty wild.
You can follow checklists, actual checklists, if you were lucky enough to have one. So along with other simulations, DCS falls into a category that's colloquially known at least in the commercial world, as study level fidelity. In other words, you don't just sit in and play a video game. And I mean, fundamentally, that's what this is. It's not the real world. There are rules in the computer world that you can bend, but it's about as close as you and I are going to get to an aircraft like that, a combat aircraft, F-16, F-18, et cetera. So while we can't escape the fact that these things are computer games, they really do capture reality in an incredibly interesting way. And so along with another handful of simulations, which we'll talk about a little bit later on in this presentation, it's really easy to familiarize yourself with the technical nature of these aircraft, and it's important to do so before diving in. Next slide, please. And one thing to note as I'm going, I've got a lot of slides. If I run out of time, we'll pick up later. So I think you went one slide, maybe too much. Oh, maybe not. Okay, go ahead. So I kind of gave a little video explanation here. This is a carrier launch from the backseat of an F-14. I chose this one because not many people know what the backseat of an F-14 even looks like. I'm just sitting here. This is actually online with a buddy of mine. And I don't know if the sound will go through Zoom. Hopefully it will share. If it doesn't, really the idea is imagine yourself experiencing this in VR. And that's something that's hard to capture on a two-dimensional screen. But what this kind of simulation in this environment is what you lose on a screen is a sense of scale, a sense of movement, a sense of presence. Imagine it's out of oh man, that thing is 30 feet long. That missile must weigh half a ton. And so in a world otherwise detached from beeping of avionics. Imagine that on a motion platform. Have a sense of stopping feel when the wheels leave the deck. Well, this flap's coming up as the airplane lurches. In the present, off had virtual reality experiences in flight
I'll add, through Tim, stepping me through like startup procedures and flying an F-16 and the AH-64 and I can tell you that from my experience and what I've done the research on as well, the community that builds these models, everything's faithfully recreated to the model that they're building towards. So everything that you see here, the buttons, and the knobs and everything, they all work. They all translate into an event. They actually have all activities associated with them. So it's not just for eye candy, right? When you see the button up there or the knob, it actually does something. So
They've even gone so far as to model radar reflections
that's amazing.
for all of these
Yeah,
systems. So
yeah.
your radar will have the same limitations in many ways as the real one, is as close as they can come. So next slide, please. I'm gonna hesitate. I've got a few little embedded YouTube links, but man, they're a little dodgy in these kind of presentations. So I'll refrain from those. But kind of going back to what I talked about with study levels, many of these simulations are that level of detail. Kind of as Dr. Pritchard mentioned, all those buttons, knobs, and dials, they're not just for show. There are some that aren't. Obviously, you're not going to be working with classified information in a commercially available sim. So there's some things that are left out. To give you an example, the IFF systems in some of these aircraft are greatly simplified. They're not the real world.
Yeah, yeah.
They're close, but they're not what you would normally see. The fundamentals are there. But the cool thing about these is you can actually use a checklist. You can taxi with a taxi diagram. You can use radios with other aircraft in these simulations with other people. In that video you just saw, there were 2 humans in that aircraft, in a digital presence anyway. And then navigation. You can use VORs, ILS. You can fly instrument procedures. Getting back on that carrier, you can fly a instrument approach to that carrier. And it all works as you would expect. So while none of these things are substitutes for actual experience, I know some actual fighter pilots that I fly with in these simulations are like, yeah, they're cool. You can practice things. Obviously, they're not the real deal. They're about as close as many people will come. And the experiences are relevant. So the implication is that everyday people, you and I, and even trained pilots can get something out of this. And the bonus is almost all of these things are VR compatible, and they would work very well in a 7DOF environment. Next slide, please. Let's talk a little bit about some of the research opportunities here. So there's a lot of things going on in the research world, especially with simulation. I mean, you look at just about any avenue, particularly in aviation, there's always things going on in the human factors world, especially as we look at the rise of the UAS universe, where people are removed from these systems. One of the big questions that arises is, how do you add the people back in? And that's a whole separate topic for another day. But with regard to these particular simulations, and particularly DCS and some of the other offshoots, there's a lot of stuff going on. The examples are human factors. There's a couple of research papers. I've linked them in the on my resources slide at the very end. So for those who want to explore some of this information, or even just look at some of the images I posted, I try to provide citations in some way. But DCS, headsets, eye tracking to monitor pilots under stress. The idea is you can take a fighter pilot, put them in a situation, and take a look at how they're reacting to a situation, whether it be threat aircraft, detected on some bearing that's coming right at them, and they're running through checklists, turning on systems, getting the radar ready, master arm up, and all that other good stuff, or evaluating autonomous algorithms for air-to-air engagement. Anyone else watch the DARPA AI fighter planes that really absolutely annihilated a human pilot? You can run those kinds of simulations in this kind of environment. Maybe not this exact software, but those things are possible with this environment. And you could put a pilot in a digital presence inside a simulation like that. Aircrew training, we'll talk about some actual real world examples of that's going on right now, and has gone on roughly the 2018-2019 timeframe in the United States, and current stuff going on in Ukraine presently. And so next slide, we'll look at some real world examples of that. So this is an actual thing that happened. In 2018, they set up this, the 350th Training Squadron set up this training environment at Davis-Monthan Air Force Base. They actually used DCS World to train real A-10 pilots. That was actually one of the flagship modules for the simulation that came out on the market. And it's down to, again, every switch, button, and knob. So while there are obvious elements of fighter jet training you lose in this environment, for example, you're not going to go pull 4 9Gs on that simulator 7DOF table. At least, man, I hope not. That'd be very bad. But from a procedural standpoint, learning how systems interact, learning communication procedures, talking with other people in that environment, it's very relevant. And basic flight characteristics to a point. There's a point at which you need to augment simulated training with real world training, but that line is starting to blur a little bit. Those two things will never merge, but it's getting closer. And so these setups are relatively simple. VR headset, replica A10C throttle, you can buy them on the internet for very little. Rudder pedals, computer terminal, and module. And one of the goals here is to evaluate the capability to deliver effective, innovative training with commercial off-the-shelf equipment, stuff that you and I could just go buy. It was relatively cheap compared to firing up an actual jet, and relatively reasonable to assist with familiarity with systems, controls, and basic procedures. So going on to the next slide, this is a little more recent and a little more relevant, and it's actually a really interesting and there's a lot of ingenuity here. Right now, for those who've been following world events, there's some very unfortunate things going on in Ukraine. And one of the things that's happening is Ukrainians are trying to acquire aftermarket F-16s from NATO partners. Netherlands and a couple other countries are giving them F-16s. The trouble the Ukrainians are having is they have been operating Eastern Bloc aircraft, MiGs, Sukhois, etc. And basic familiarization with these aircraft, they've been using this software, DCS, virtual reality, Quest 2 headsets, and some really basic things to familiarize themselves with how these aircraft work. And again, no substitute for actual flight training, which they are actually doing, but they've been learning how these aircraft work. And very similarly to what the United States Air Force is learning, they're learning how the cockpit's laid out, where the controls are, how these different systems may interact, what things may look like on a radar screen versus what they're used to in a MiG. So that's the idea behind some of this stuff. And one thing to note with training applications such as this, there's also a need to analyze the effectiveness of that training. How is the aircraft performing? For example, the cool thing you can do with all these different things is you can go pull a ton of G's and not fall out of your chair or fall asleep, right? That's the cool thing about this. And also the bad thing, because you're not actually there. But there's some neat software that allows you to analyze how that is performing. Am I actually making the aircraft perform within its envelope? Am I exceeding its envelope? And so on the next screen, we'll look a little bit at some of the analysis software that's available. So this is a pretty cool tool called TacView. I'll go ahead and once I run that video, I'll apologize for my subpar gunnery. My buddies on the internet give me a hard time for that. But what this tool is it's used in the real world. The French Air Force actually uses this for briefing, debriefing, and going over missions. And this is the bare bones stuff. But essentially what it allows you to do is look at your aircraft or any other aircraft in the simulated environment, and you can look at its performance. How fast am I going? How tight am I turning? What is my radar doing? And you can export a lot of data, far more than you can see here, into a CSV format, and you can actually analyze it. So if I was a pilot, I'd want to know, hey, am I actually holding that airplane at its maximum performance in a turn? Am I too slow in responding to a threat? Am I totally terrible at shooting my aircraft's gun, which this video highlights? And the neat thing about this software is it's relatively affordable, very accessible. It's available for free in a lot of ways. This plugs into a variety of different simulation platforms, some of which have nothing to do with combat. It's compatible with X-Plane. It's compatible with a program called Falcon, which I'll talk about a little bit later. It's compatible with DCS. And you can go through step by step and analyze how a pilot did or what a mission would look like. So pretty neat little software plugin, and it allows you to really look at what's occurring in the simulated environment, and it's probably one of many tools. This is the one I'm familiar with. I'm sure there are others.
Yeah, and again, like DCS, TacView actually, and if you go and check out the email that I'd sent out, there's a link in there. The French Air Force is using TacView for after action reports and doing flight analytics. Yep. So it's not just, hey, this is a analytics tool for a gaming environment. This has, again, real world implications and applications.
Yeah, and kind of to build on what Dr. Pritchard said, really all this software does, it acts as a way to gather telemetry from whatever system that may be, a flight controller, autopilot, black box, whatever you want to call it. It takes in telemetry and represents that telemetry in a 3D environment. That little icon there, that's an F-18, it could be anything. It could be whatever airplane it is. It could look like a paper airplane. But really what it does, it allows you to process telemetry, view it in a 3D space, and look at the characteristics of that aircraft. What you see here on this little flag is indicated airspeed, Mach number, altitude above the ground, AOA, Gs, and turn rate. Those are things I'd be concerned about if I was, fighting a digital adversary like I am there. If I'm flying in a digital F-16, how many Gs I'm pulling is probably more important than in the F-18, which I really care about my turn rate a lot, or at least my AOA. So anyway, there's different ways to look at this data. And as we go to the next slide, we'll kind of go into a little bit about the student engagement and talk a little bit about the virtual fighter wing student group that was recently, the student club that was recently started here on campus, and kind of builds on some of the engagement parts of these, kind of the fun and flashy that the students are enjoying so far.
And I think there is a question
Yes.
from Fred. Yes, sir.
Fred.
Hi, yeah, it's not really a question so much as I just wanted to bring into focus the fact that this TAC view piece, what you're really talking about here is a tool for assessment of student learning.
Yep, that really is.
And so as we talk about assessment in other venues, this is a tool that's exactly designed to do the kind of thing we're trying to do with our assessment systems across the whole campus.
No, that's exactly right. It allows an instructor to look at a set of events, whether it be a mission or just an engagement or something after the fact, and say, well, you know how this aircraft is supposed to perform, but at this point in this engagement, here's something you missed, here's something you forgot, or hey, you did this great. Here's how we can improve even more. So yeah, that's exactly what it is, Fred. 100% spot on. It is a tool for assessment. So excellent observation. Thank you. And I'm going to dip out of the frame and we'll continue on. Talk a little bit about the student engagement aspect. How are we doing on time, Dr. Pritchard?
We are good.
Sweet. So this next portion of the slide deck, I actually kind of prepared it as an interesting pitch session for a student club. And so far we've gotten some pretty good traction. And what I will caveat this section by saying is what's not shown here are some of the really cool presentations and reports that students have made of their own free will without being graded. Some really detailed videos and PowerPoint slides and presentations on aircraft, on tactics. They're really getting interested and really into this. And I thought that was just incredible how much effort these students have expended just because they enjoy it. One of our students that participates in this is a digital media major. He made a really cool video that I really wanted to show, but it's kind of long. It's like almost 5 minutes long. He spliced a ton of video together, music, real footage, DCS footage. And one of the things, if we have time, I can show some like a trailer for one of the aircraft. Sure. One of the things to note is this software crosses uncanny valley in a lot of ways. So sometimes it's tough to tell what's real and what isn't, depending on how the footage is shot. So let's go on to the next slide. It's kind of my title slide, Virtual Fighter Wing. In a little bit of a diversion here, I get a little bit out of the DCS realm and talk about another piece of software, because as we start talking about students, they may not always have a ton of money to drop on $80 modules and a ton of peripherals. So for this aspect, I kind of say, how can we bring these experiences, these fun things to students, and how can we get them involved, both in the 7DOF platform, in the AR, VR initiatives, and have some fun. And since we are a largely aviation-driven campus, this seemed like a natural extension that brings a lot of the things that make this campus strong together to do something interesting, engaging, and quite frankly, a lot of fun. So next slide, please. So some of this may be a little bit of a rehash of some material, but it's a little bit different in the sense that I'm looking at how you can get students involved in some of this stuff. So the goals of the Virtual Fighter Wing are to capitalize on our strengths as an aviation-centered campus and create an avenue for student engagement and student life, which so far has been incredibly successful. To encourage use of these new technologies. So we have this 7DOF platform. We have this AR, VR lab. How do we encourage students to take advantage of these resources? How do we get them to learn? How do we get them to capitalize on these things? And so we can provide some new areas to explore using commercial off-the-shelf simulation technology. And so as we go to the next slide, if you would please. As we kind of talked about, these simulations are incredibly sophisticated. So we've kind of been talking about this in terms of research and the 7DOF platform. But one of the things that I don't want to miss is these things are designed to run on a desktop computer, something many of you probably have at your home. And some of these students are doing this with a laptop and an Xbox controller. Some of that's a little more effective in some ways than others, but it works. And they're real popular among pilots, aviation enthusiasts. We'll talk about we've talked about DCS a bit. We'll also talk a little bit about Falcon and some of the other opportunities it brings in terms of people who want to get involved in this, who want to explore combat flight simulation in virtual reality, augmented reality, et cetera. Not shown are some of the really crazy cockpit builds people have built for this stuff in their home cockpits. You've got guys out there with a full A10 cockpit with curved screens, triple projectors. It's kind of nuts. You also have people that have 7DOF platforms in their garage. Like, this is stuff that people really enjoy. And also actual screenshots from here on out. So this is the level of detail you'll see. So it really represents an opportunity to bring, students together, build on our aviation community, have them work together to accomplish things, either in a virtual campaign or even compete. As Dr. Pritchard mentioned in the email that went out the other day, one of the maybe medium to long-term goals is to build up a competition team. There are people that compete for this, doing this dogfight competitions, oftentimes for charity. Folds of Honor, some of you may be familiar with that. They are one of the sponsors of a competition that occurs every so often, which is kind of cool. So they promote engagement, and I've provided 2 examples of opportunities to be taken in parallel. So next slide, please. And we're starting to kind of come to the end of it. So hopefully we'll leave enough time for questions. So I kind of took 2 approaches here because, as I mentioned a little bit earlier, DCS, really cool. You can get the base simulation for free, but the aircraft are sold as modules, anywhere between 50 and 80 bucks a piece. That can be a little bit cost prohibitive for a college student who, they've got a lot to worry about. Falcon, the other opportunity, is literally a modification for a piece of software that it was written in 1998. Anyone ever hear of Falcon 4.0 back in the 90s? Anyone? Just me? Probably. Okay. Mo? Yep. Dr. Mo.
Dr. Mo.
This is essentially that, where the community took it, ran with it, and continued to build it for about 25 years or so. And it is now the same level of technical fidelity as DCS, just visually not quite the same. So next slide, please. So talk a little bit about Falcon. Probably one of the best F-16 simulations out there. You've got engineers that have been building flight models of the engines and dynamics for years. It has a really cool dynamic campaign structure, which is a whole discussion in itself. Most of you probably aren't familiar. It's essentially built on concepts that are encapsulated in the old Air Force TAC Thunder campaign simulation, which we won't go into today, but it is a virtual environment, a living world where people are part of an entire conflict and you are a fighter pilot at that point. And the cool thing about that is it's functionally fighter pilot D&D. You have people that will say, here's the thing that needs to happen. Here's how we're going to accomplish this. This strike package may hit this SAM site. This strike package may sweep for fighters. This strike package may protect some command and control aspects. You have human beings, people communicating in the simulated environment with radios and all that other stuff doing that thing. So it's pretty cool. And it's $10, pretty affordable. Next slide, please. And so kind of the vision for the student group for this would be, they would have to do a lot of their own self-study. A lot of this does require that level of knowledge, but there'd be some basic training because it's a common system. Difficult to do in DCS. You've got a lot of people with different interests. And then there'd probably be some checkout procedure at some point. And then you would have students work together to accomplish some objectives through some ongoing campaign that would take place over the course of the year. So the idea is long-term learning, ongoing engagement, and something that once it gathers momentum, just keeps going. And next slide, please. Then we got DCS. We've talked about this a lot, but this is a little more in-depth overview of what it actually is. Standalone combat flight simulator, incredibly detailed environments. They're actually working to build an entire globe in this, the whole world. So anywhere you want to fly, it's modeled, it's there. Kind of similar to what Microsoft Flight Simulator recently did. Trouble with that is you're streaming petabytes of data. And so there's a lot of network requirements there. I was curious to see how these guys do it. Highly detailed aircraft, more expensive, however. And so that's why I'm trying to create options for students to get involved that don't require you to dump a ton of money into software, and trying to provide ways to provide peripherals, either through club funds, use of university resources, ways to get students engaged that don't require them to go drop a ton of money. And there are ways to do that, and we're exploring them. But graphically beautiful, no dynamic campaign, at least not yet. And you can create your own scenarios. We've actually had some students building their own scenarios, and they'll haul their computer into the dorms every so often and invite other students to come play, to come complete challenges, to do things. It's been a lot of fun to see them get engaged. Next slide, please. So this is the more competition focused thing. Probably tough to see on your little screen. There's actually a little poster here for one of the competitions. There's several regular competitions where people go and test their skills against other humans. Same thing. It would be some kind of instruction, and we've been doing a little bit of that as a group every other Sunday, talking a little bit about basic systems, how to fly the thing, some basic concepts. Obviously, I can't go and say, I'm going to train you and train you, but it's self-study and they're learning quite well. I found if they are allowed to do something they're interested in and you can motivate the students to just say, go learn it and have fun, and then give them an opportunity to just play with the material, man, they have and they are. And so no checkout procedure or something like that here. It's just, hey, you want to go compete? Let's go do it. And then internal competitions, maybe internal brackets, who can, who do we send? So there's some cool ideas that I've been kind of building here. And so far they're kind of getting off the ground, but I'm seeing a lot of momentum and a lot of real positive things from the students so far. So next slide. And that's pretty much it for my presentation. So I'll leave some time for discussion, questions, and anything else anyone may have. And at the same time, I'll kind of step over here more into the camera so I can also engage with folks on Zoom. So I see Dr. Khan, you got your hand up.
Hey, a good presentation. I just wanted to know is when you're getting this data for these aircraft that you're saying that's so cheap, like $99 or something like that. Is this coming straight from the Department of Defense or is it the simulation data?
No, and that's a really good question. So there have actually been some interesting stuff happening in that realm. But for the stuff that's being developed, at least the stuff by the community, a lot of it is subject matter input and engineering analysis. So for example, there's actually a NASA technical paper on the F-16, technical paper 1538, write that down. NASA technical paper 1538, that they essentially published all the flight dynamics of the airplane. Yeah. And there are some engineers that also—
It's not a quick read, by the way.
It's not a quick read. I think I sent it to Dr. Pritchard. But there's some engineers that would say, I'm going to take this data that NASA generated and published, and I'm going to work this into a simulation model. And so that's where a lot of this comes from. On the commercial side, they'll build digital models and put them in a digital wind tunnel to get a lot of the information. And in some cases, on DCS, they do have input from actual manufacturers. Like Boeing actually helped and loaned resources to develop their F-18 module, but they're obviously not going to give anything away that's classified or otherwise restricted data. So there are some things that obviously aren't perfect and things that are not shared.
Yeah, so I had a question for Michael or anybody else who's from the AI point of view. Does the platform itself, does 7DOF platform that you're talking about, does that itself, it's basically general, I mean, it's not an AI control system, right? It's probably
Correct.
like standard control system, right?
Correct. Yeah, correct.
Okay.
And actually that's, yeah, and yes, you are absolutely correct. And I wanted to pass some questions over to Mo and Troy as well. But yeah, you're right. That's right.
All right,
Now,
thanks.
yeah, and so the now with that said, as it relates to the 7DOF, yeah, it's just a standard control system. But as it relates to some of the AI within DCS, like you can create adversaries that are actually AI enabled, but that's not related to the 7DOF platform itself. That's kind of, think of it as a non-player character in a gaming universe. So there are AI elements within the DCS world though. So
Yeah, interesting.
Yeah.
Thank you.
Yeah, absolutely. And I want to say something here too, because this comes up on the military side when they talk about multi-domain operations. And I was just at Command and General Staff College, and we went through a wargaming simulation. Dean Petrescu was there, and it was a very interesting exercise because we went through this wargame exercise. We went through this huge simulation. It was a World War II sim. And then I kind of perseverated on the outcome of the game, but they actually stopped the gameplay and said, actually, that's not the outcome. What we were really interested in is how are you teaming? How are you collaborating? How are you communicating? We wanted to know as planners, what is your process of going through and managing the information space and the unknown? And I was like, oh, what a great idea. And so when you think about like that and take the military aspect out of it, right? Even when we do training here for professional pilots, when we do stuff like that, it's a multi-domain operation, right? You have to communicate with ground control. There's a whole airport management infrastructure that's separate from the airspace, right? There's a lot of elements there that kind of make it a multi-domain operation, even though it's a non-military use of the word. But there's a lot of aspects within this game, within the simulation, within the process, I'm sorry, rather within the 7DOF and DCS world that, yeah, there's a process element to it as well that we can teach, right? For the teaming, collaboration, communication. So it's pretty exciting.
Thank you.
Yeah, and I think Dr. Mo has
Yeah. So I just wanted to talk a little bit about, as we were talking about teaming, collaboration, as we're working to get this platform set up. It's been kind of a interdisciplinary project at this point. I've been working with students in the electronic and computer technology areas, mechanical engineering, robotics, as well as our computer systems folks. There's a lot that goes into the 7DOF platform, everything from wiring on the electrical side to building out. What we want to do is create modular platforms that we can easily switch from like a flight sim to a land-based like racing game, you know, or not game, but simulation. So the interesting thing, and I think the really cool thing about this platform is how it brings all of our different majors together to, you know, solve these problems. Really touches every single major on our campus. So that's pretty interesting. Troy might want to elaborate on that a little bit too.
And Tim's already alluded to this fact too, that it's not just for a particular one use case, or not just necessarily for flight simulation, although this platform is great for those types of simulations. But really the purpose for why we got this platform in the first place is to up our skills on being able to build one of these simulations from the ground up. So there's a lot of gaps we know that we have in figuring out how to not only get the thing into the building, but to actually build it all up, get a cockpit of some kind on here for whatever it might be, whether it's the Baja car or for a flight simulator. But there's also the software sides of it, and how do we actually develop our own software, not just use something that's pre-built, but build a simulation from the ground up on the software side. So all of this is part of what we want to be able to have the capability of doing. We will be having Kay Aries coming on here in the next couple of years. Our partnership with Pure Imagination Studios is going to really help us close some of those gaps, but we don't want to have to rely on them for everything. What we want to be able to do is be equal partners in this partnership on the technology and development side of these things. Not every project that comes is going to be something that they're going to want to jump on. It's not going to necessarily have a commercial purpose for them, but for us on the education side might have a great purpose for us and a way that we can contribute to that. So that's also part of this whole ecosystem that we're trying to build here. And this is one step in that. We also have our XR lab, but we're going to have a whole building dedicated to doing this kind of work here in the next couple of years.
Yeah, to reinforce that, and Troy had mentioned some pieces about the Baja car, and there is a robotics telepresence piece to this that I think is not that we've kind of touched on a little bit. And so when you think about the motion platform, it's not just for simulation, it's also for being able to get on the motion platform and be able to robotically or I should say remotely dial into an external entity. So for example, one of the use cases that we're exploring is being able to remotely pilot a large aircraft, not just a drone, but like a Cessna 182. So I know that that's been stuff that we've talked about as a use case, that we can actually use this for that. And what we're building on right now will be able to springboard us into being able to get towards that capability. So yeah, it's exciting. It's very exciting. So questions for Tim?
So Tim, what are your thoughts? You know, you're a UAS expert. How do you see this platform tying into like the advanced air mobility research that we're doing?
So that's actually a really great question. Advanced air mobility is kind of, as I'm sure a lot of you know, really kind of the next big frontier for UAS. Small UAS, the under 55 pounds, 400 feet, as far as the regulators go, that's kind of small potatoes. That's the beginning. For advanced air mobility, this sort of platform can give us the potential to look at new ways to train pilots potentially for these vehicles that operate in very new and novel ways. I mean, let's think about what we've all seen for advanced air mobility: vertical lift, weird hybrid systems, things that don't behave like a conventional aircraft. And there's going to need to be new ways of thinking, new avenues of approaching these problems in aviation. Because right now, I'm trying to figure out, how do we even certify these systems? We are seeing things that we've never seen before. So from a training perspective, this might open some pretty big doors. And from a general UAS perspective, we're looking at the opportunity to add a human presence, which is conventionally lacking from an uncrewed system. So imagine, if you will, a system that experiences a fault that in the conventional world, all I have is a set of instruments. I may see a little RPM gauge that may say, oh, my engine died. But if I don't see that, I have no way of knowing, other than my airplane just doing something and me not being able to understand that as quickly as I need to. But imagine then a motion platform where I get immediate feedback to the performance of whether it be an advanced air mobility vehicle, which will initially be piloted, by the way these will start entering the airspace. It'll allow us to really identify and add that human physical presence to a system that may be, at least long-term, maybe trying to remove itself from that presence. Maybe it'll be in the future piloted by AI or some system. This would allow a way to help validate those flight control algorithms, how the aircraft behaves, in a way that adds the human presence, removes some risk, but also allows us to deeply analyze how something like that might perform. So I hope that answers your question. There's a lot of opportunity in the advanced air mobility space with a system like this. And I see Dr. Khan, you got your hand raised.
So very exciting. So I was just saying, like, okay, so I'm flying through without a pilot in command, no pick, right? Autonomously through an urban canyon, right? Can we use this system to keep on running simulations and gathering data with regards to like a fixed, let's say New York City canyon or something like that, right? We know what the building formation is. We probably know what the satellites are going to be, where they're going to be at what time, right? And in that case, if you can generate all of that, you can probably find the kind of let's say harmful elements that can affect you while you're passing through that corridor, right? So if you could repeatedly do lots of simulations and train it in the AI way, that'd be one way of getting to the autonomous thing using a system like this, I think.
Well, yeah, and you're exactly on, because it's not even a simulation, because what ends up happening in that, like when you look at NVIDIA's stack, their tech stack, Isaac, Osmo, and then on the hardware side, Thor, they're actually using exactly what you described to train human robots. So how they're able to do what they're doing with the new, like Figure 1, if you look at what they're doing, they're actually taking humans, putting them into a VR headset, remotely dialing into the robot, which is, what did we say, Troy? Like 5 years ago, we were envisioning this. And so we were actually putting proposals together for this, for doing exactly what's happening today, but that was 5 years ago. And the idea was to dial into a humanoid robot, and then you record the movements of the person while they're in it. And then that turns into training data for the robot to reuse down the road. So that's exactly the same thing that what you're saying is absolutely critical and true. So can be used for doing that for the UAM side of it, right? And the traffic management and deconflicting traffic, but then also making the flight systems smarter as they become more autonomous. So that absolutely, that it would just be kind of instead of a humanoid robot, it's a flying robot, right? It's kind of same principles apply though. Yeah.
Very cool. Thank you.
As Troy also has mentioned, I really like that building the capacity, so down the road that, we can leverage all kinds of applications. Because I see also there is a potential for grants and other thing. Are you guys looking at, because, in Missouri, they build the fighter jets. that I don't know which model they are, but F-16s, I think they were building there because in the backyard. And also like, Wright-Patterson base, they actually fund the University of Dayton with lots of projects. I don't know whether you guys are looking at any of those funding opportunities that, having this type of capability. That any ideas on that? Or sometimes, collaborating with, people who are already getting from Wright-Patterson base, they give a lot of projects to, University of, Dayton in Ohio. So maybe collaborating with them and leveraging, that will help. Because, not everybody
needs
has
the
these
mic.
capabilities. Yeah, here, okay. You take this mic.
Can the folks online still hear me? Mic check.
Yeah, we
I
can hear
can,
you.
I
we
can
got
hear
you.
you now, but I couldn't for a while.
So you can hear me?
I can now.
Cool. So just because there's a little bit of noise here, I think, Roger, you asked if we're pursuing any grants and cooperation with folks like Wright-Patterson and some of those other places. I'd say not presently, but this kind of capability opens the door for those kinds of collaborations and partnerships. And I think that's something that is not lost on the 7DOF team. And that's like a long ways down the road. That whole Pure Imagination collaboration opens up a lot of doors for some really important collaborations with a variety of entities, whether it be DoD, commercial, other educational institutions. It really is a force.
The virtual fighter wing and then start winning some competitions. That'll be good too.
Yep, we'll see where that one goes. There's definitely drive.
That's awesome. So, any other questions from anybody online? Big thank you to Tim. Big thank you to Roy. Big thank you to Dr. Mo now. And there's a party later, so if you can make it, please come over. I think it was the speakeasy. We're going to be at the speakeasy in Slime. So that's all we have here. And appreciate it. Thanks for showing up. And we'll see you in the next installment.
Thanks.